Okay, so we'll start the second exercise. Question number 15. The figure shows the displacement time graph of four bodies A, B, C, D. In each case, state what information do you get about the acceleration. Now you just zoom this. Okay, can you see this? First case, you can see it is it is slant, but it is going to it is rising. So it can be said that it is what the acceleration is increasing. So uniform acceleration, or body is increasing uniformly. Its velocity is increasing uniformly, or we can say with a constant velocity. Second, it is decreasing with a constant velocity. Okay, so the acceleration will be zero. Why? Because the velocity is constant. Third case, it is non-uniform velocity is rising, so it is acceleration. And the D1, again it is increasing, so it is a curve, not a straight line. Whenever you have a straight line, it is a linear motion. Not a straight line, it is a non-linear motion. So first case, no acceleration. Next case, no acceleration. Third case, it is negative acceleration because it is rising and then it is getting flat. And the fourth one, it is only rising, so it is positive acceleration. Now this, draw a graph for acceleration against time for uniform accelerated motion. Uniform accelerated motion, you need to draw a graph of acceleration and time. On y-axis you have acceleration, on x-axis you have time. So it is a straight line parallel to x-axis. It is uniformly, it is going. Okay. Next, draw velocity time graph for a free fall and take g as 10. What is the meaning of free fall? Free is phokat, fall is girna, means phokat ka girna. Free fall means when a body is released such that no force is acting except gravitational force. So it is falling freely. When you throw something, it is not a free fall because you are applying force. Free fall means no force is applied, only gravitational force. So the acceleration with which Earth pulls everything, it is 10. To be exact, it is 9.8, but we take it as 10 meter per second square. So what will be the velocity? If acceleration is constant, means the change in velocity is also constant. So it will be a line which is straight as shown in the figure. Okay. Next, how is the distance related with time for motion under uniform acceleration? So what is the distance? It is directly proportional to square of the time, because acceleration, okay, acceleration is change in velocity upon time, and velocity is what? Distance upon time or displacement upon time. So denominator you will get time square. So distance, the question is, distance is directly proportional to the square of the time. Okay. Now we will solve few numericals. Okay, we'll solve this one, 23rd. 2.37a shows a displacement time graph for the motion of a body. Use it to calculate the velocity of the body for time 1 second, 2 second, 3 second, and draw velocity time graph. Please see to it which graph is given. The graph given is displacement and time. You need to draw velocity upon time. Just zoom a bit. What is the displacement at 1 second? Answer is 2. Velocity is displacement by time, so 2 by 1. So answer will be 2. Second, what is the velocity after 2 seconds? The velocity after 2 seconds is 4 by 2. So it is 4 by 2 means it is 2. Then what is the velocity after 3 seconds? It is 6. So 6 by 3, answer will be 2. So the graph which you will get, it will be a straight line parallel to time axis. It will be a straight line. You only need to focus on 1, 2 and 3. It will be a straight line which is parallel and it will pass through 2. At 2 it will be a straight line because After 1 second it is 2, after 2 second also it is 2, after 3 second it is also 2. So it will be a straight line. Okay, please ignore this. Yes, 24th. The following table gives the displacement of a car at a different instant. Draw the displacement time sketch and find the average velocity of the car. You have to draw the graph. Now you need not use the graph paper. You can only use the normal paper. That is the plain paper which we have. After time 0, distance displacement is 0. After 1 it is 5, 2, 10, 3, 15, 4, 20. You see, you will get a straight line. Can you see? It's a straight line. They are asking you find the displacement after 2.5 seconds. Now it is very easy. After 2 seconds it is 10. 3 seconds it is 15. So 2.5 will be average of 10 and 15, which is 12.5. Okay. After 4 and 5, so 4 second is 20, 5 second will be 25. The average will be 4.5. Understood? No need to solve all this. You can directly write the answer. 25th question. Again, similarly, you will draw the graph. Now on x-axis you will take time. Always on x-axis you take time. So it is 0, 1, 2, 3, 4, 5, 6, 7. On y-axis we have displacement. Now you see displacement given as 2, 6, 12, 12, 12, 18, 22, 24. It is non-uniform. So you will not get a straight line. You will get some random numbers. I have seen students writing on y-axis, they will take the same values. No. Remember the rule of mathematics or graph. On x-axis and y-axis, whatever number you take, it should be after regular interval. So you can take 2, 4, 6, 8, 10 or 5, 10, 15, 25, 30 you can take it. Okay. When you plot it, you get this graph. The question is total displacement between 1 and 5. So at 1 second, after 1 second it was at 6 and after 5 seconds, where is it? Check karo. It is at 18. So from here also you can say 1 second it was at 6, 5 second it is 18. When you subtract it, you get 12. Next is the average velocity of 1 and 5. Velocity is displacement by time. So displacement you have found to be 12. What is the time? 1 to 5. So if you subtract, you get 4 seconds, not 5 seconds. So 12 by 4, the answer will be 3 seconds. Okay. 26th question. The displacement of a body is shown at different times. Calculate the velocity between 0, 5, 5, 7, 7 and 9. Also the average velocity during the time 5 and 9. Now 0 to 5, check the velocity 0 to 5. So at 0 it was at 0, at 5 it is at 3. So what is the displacement it has made? 3. And time 0 to 5 means 5. 3 by 5, answer will be 0.6 meter per second. 5 to 7. Now check. 5, the displacement was 3. After 7, the displacement is 3. Means there is no displacement. They have not moved. The body is at rest. It will be 0. 0 upon anything is 0. 7 to 9. At point 7, the displacement was, they were at 3. After at 9, they are at 7. So what is the displacement? 3 to 7. So 4. And what is the time period between 7 and 9? It is 2. So 4 by 2, answer will be 2 meter per second. Last one, calculate the average velocity 5 to 9. So at 5, it was at 3. At 9, it is at 7. So what is the displacement? 3 to 7 means 4. And what is the time from 5 to 9? It is 4. So 4 by 4, answer will be 1 meter per second. 1 meter per second. This is the answer. Clear? Next is question 27. The displacement time graph is given. We need to find the average velocity in first 4 seconds and displacement from initial position after 10 seconds and time after which he reaches the starting point. It's a very easy question. Average velocity of 10 seconds. Now first 10 seconds, what is the displacement? You can check. Okay? Average velocity, first 4 seconds, I'm sorry. After 4 seconds, what is the displacement? Answer is 10. What is velocity's formula? Displacement upon time. So 10 upon 4, answer will be 2.5 meter per second. Next is, they have asked you to find the displacement after 10 seconds. So after 10 seconds, if you see, displacement is towards the negative, that is minus 10. Question is, after what time we come back to our original position? So original position was 0. We come back to 0 point after 7 seconds and again after 13 seconds. So answer will be 7 and 13. Okay. Next. Let us study the diagram. So two cars are given, A and B. Okay. Can you tell me whose velocity is more? The one with steeper slope. So answer is A. The slope is more. A and B both meet at time is 2 hours and at 80 kilometer. Okay. A starts from 0 and B starts from 40. So B is ahead of A at the start. So this I understood. Now we will understand what is the question. Distance by which B was initially ahead. So we know the answer, it is 40 kilometers. Velocity of A and B. What is velocity? Distance upon time. So both of them meet at 2 hours. But A started from 0. So its speed will be 40 by 2, that is 20 km per hour. And B has only covered, 0 to 80, they meet at 80. So 80 by 2 is 40 km per hour. But B has started from 40, it has reached 80. So it is only 40 kilometers it has moved in 2 hours. So 40 km per hour. A is 40 divided by 2. A is 40 km, B is 20 km per hour. This is the calculation for both. Because A has covered 80 km in 2 hours, B has covered 40 km in 2 hours. The time in which A catches B, answer is 2 hours. And the distance from start when A will catch B, it is 80 km. 29th. Shows the velocity time graph. You need to find displacement time graph at these 2 seconds. Now from velocity time, how should we find the distance? You have to find the area under the curve. Now if you check 1 second, if you check, the area is, the figure is a triangle. So area is half into base into height. So half into 1 into 2. So 2 and 2 get cancelled, you get 1. For 2 seconds, again it is a triangle. Half into base into height. So half into 2 into 4. Answer will be 4. And for 3 and for 4. Similarly you just find the area. From velocity time graph, for displacement we need to find the area. So you will get answer like this. 1, 4 and 9. Okay. So you will get something like this. It is a non-linear motion. Next question, 30th. Given below shows the velocity time graph for a car starting from rest. The graph has 3 parts, A, B, B, C and C, D. How distance traveled in part A is determined from the graph. From velocity time graph, the distance is found by finding the area under the curve. Compare the distance traveled in BC and AB. Now BC, the area below this, it is a rectangle. And AB, it is a triangle. So I will use the formula area of a rectangle upon area of a triangle. So area of a rectangle will be length into breadth. You can see the length is VO, breadth is T. T went to 2T, so it is T. So you will get V naught T. AB, the triangle AB, the area below AB is half into base into height. So half into T into height is V naught. When you divide both of them, so when you divide, you will get 2:1 because V naught T upon half V naught T V naught t gets cancelled. Half will go in the numerator, it will become 2:1. Which part of the graph shows uniform velocity, acceleration and retardation? Uniform velocity means BC, you can see the same velocity. Acceleration means the rising curve, AB. Retardation is CD, it is a falling curve. Okay? Is the magnitude of acceleration higher or lower than retardation? Which graph is more, AB or CD? Which is steeper? CD is steeper, so retardation is more. Next, they have asked to find the magnitude of acceleration and retardation. Okay, so answer is this. From velocity time graph, you will find the slope. You have studied in maths. AB, the slope will be y2 minus y1 upon x2 minus x1. Similarly, for CD, you will use the same formula. So when you use the formula, you get this. Slope of AB will be V naught by t. Slope of CD will be V naught upon 0.5t. When you divide V naught get cancelled, t gets cancelled. 0.5 is nothing but half. So you will get the answer as 1:2. Okay.